Okay, let's have a look at question 9. Okay, so question 9 is the next calculus question in the paper. It's got to do with cubic functions. Okay, and it's going to test concavity and your ability to use derivatives. Okay, so it says the sketch below is the graph f of x, which equals to x cubed plus ax squared plus bx plus c. The x-intercept of f is at 3 and 0, and m, where m lies on the negative x-axis. They then give you that k equals 0 and negative 3 is the y-intercept, and then they say m and n are turning points of f. Okay, so all important information over there. So 9.1 says show that the equation f is given by f of x equals to negative x cubed minus x squared minus 5x minus 3. Okay, alright. So let's have a look there. We know that if we look at the function, okay, m is sitting on the x-axis. So therefore, because the turning point is on the x-axis, okay, that means at that point there we've got 2 times x-intercepts. Okay, which means the function is going to look something like this. We don't know what that intercept is. Okay, so that's what we've got to find. So we have f of x is going to equal to x, okay, plus or minus, we can call that variable anything. I'm going to call it a, okay, squared, and then multiplied by, let's see, that is x minus 3. Why? Because this intercept here is 3, so therefore we have x equals to 3, so therefore x minus 3 equals 0. Okay, now we have this coordinate 0 and negative 3, so we can solve for a. Okay, so I'm going to make this plus a. So we have negative 3 equals to 0 plus a squared, and then that is then 0 minus 3. Okay, and then from there we end up with minus 3 equals to, let's see, negative 3a squared. So therefore 1 equals to a squared. So therefore this implies that a equals plus or minus 1. Okay, so it can't be plus 1. Why? It can't be negative 1. Can it be negative 1? Okay, we're then ending up with x minus 1. Okay, yeah, so it has to be plus 1. Why? Because we end up with x plus 1 equals 0. So when we solve for it, we get x equals negative 1, which means we're sitting on the left hand side. Okay, so we have f of x equals to x plus 1 squared and then x minus 3 squared. So if we factorize this out, this is going to then be x squared plus 2x plus 1, okay, and then multiplied by x minus 3. So now we're going to distribute the x to everything and then the negative 3 to everything. Okay, so what do we end up here with? That becomes then x cubed plus 2x squared plus x minus 3x squared minus 6x minus 3. Okay, which then if we simplify, we then get x cubed minus x squared and then minus 5x minus 3. Okay, and that's exactly what they wanted. Okay, now 9.2 says calculate the coordinate of n. Okay, so n is a turning point. Okay, so what you guys should know is that your turning point equals to the derivative equal to 0. So we've got to find f prime of x equals to 0. Okay, so let's find f prime. So f prime of x, okay, is then going to equal to, okay, so f of x equals to x cubed minus x squared minus 5x minus 3. So this now, once again, we multiply it down, minus 1. So it's 3x squared. Then multiply down, minus 1. Minus 2x to the power of 1. Okay, that's the power of 1. So multiply it down gives you minus 5. Okay, and then 1 minus 1 is 0. So x becomes 1. And then the derivative of a constant is always 0. Okay, so now this is my derivative, and that's got to be equal to 0. So now we've got to solve that. Okay, which means let's have a look there. So we need the multiples of 5 such that when we multiply together, we still get negative 2. Okay, keeping in mind the 3 there. So the multiples of 5 is 5 times 1. Okay, those are the only ones we can use. So therefore the two brackets is going to be 3x and then x, and then let's have a look. The number needs to be negative, so therefore 5 is going to take the negative and then plus 1. Okay, so therefore we have over here, we have this implies 3x minus 5 equals 0, or x plus 1 equals 0. So this gives you then x equals 5 over 3, or x equals negative 1. Okay, so the turning point we now need to find. Okay, if we plug negative 1 back up top here, we're going to end up with negative 1 cubed, so it stays negative 1, minus 1, plus 5. So if we substitute that back in there for x equals negative 1, okay, we're then going to get negative 1 minus 1 plus 5 minus 3. So what do we get there? Negative 2 minus 3 gives you 5 plus 5, that equals 0. Okay, so we know that n is not at 0. Okay, we know that n is actually sitting quite far down. So therefore the x value must be this 5 over 3. Okay, so now we're going to substitute 5 over 3 back into the function over here. So this one's not applicable. Okay, so substituting 5 over 3 back into the function and solving it, you plug that into your calculator, you're going to get a value of, so f of 5 over 3, you then get an answer of negative 256 over 27. Okay, so therefore n's coordinate, please make sure that you do write down the coordinate after it, is 5 over 3 and negative 256 over 27. Okay, now 9.3.1 says for which of the values of x will f of x be less than 0. So what are they asking there? They're asking where is the function below the x-axis. Okay, so if you look at that whole thing, it's always below the x-axis up until x is 3. Okay, so for 9.3.1, the answer is over there, is where x is less than 1. Okay, but we can't have x equaling to negative 1. Okay, the reason for that is if x equals to negative 1, then we end up with 0. Okay, and we want strictly less than 0. So we can't have negative 1 where it has that touching point. Okay, so we can't include that one. Okay, but otherwise it goes on negative to infinity. Okay, then it asks FB increasing. So where is f increasing? That means where is the gradient positive? So we can see that the gradient is positive starting from down here. Okay, the function's increasing, 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 and then at this point is the turning point. The function decreases up until this point, and then it increases again. So that point there is given as negative 1. Okay, and then decreases up to this point here. That point there is 5 over 3, and then increases again. So we can say that the function is increasing for where x is less than negative 1, or where x is greater than 5 over 3. Okay, remember, when something's increasing, it means that as x, so if x1 is greater, if x2 is greater than x1 and y2 is greater than y1, then we have it increasing. So we can see our y is increasing as x increases. Okay, now 9.3.3 says f be concave up. Okay, so concavity always deals with second derivative. So they are asking is where is the second derivative greater than 0? Okay, that's how we know it's concave up. Okay, so we know that f prime of x, we found that out, that was equal to 3x squared minus 2x minus 5. So we want f double prime of x. So that's going to equal to, let's see, 2 times 3 is 6x, 2 minus 1 is 1, and then minus 1 times, okay, remember there's a 1 there, 1 times negative 2, that's just negative 2. Okay, so we're finding where that is greater than 0, and then you'll see that x is greater than 1 over 3. Okay, so from 1 over 3 onwards, the function is concave up. Okay, alright, now the last one is quite a nice question. It says determine the maximum vertical distance between the graph f and f prime for the interval -1 between -1 and 0. Okay, so what are they asking? They're asking if we take the derivative of this function. So we know that the function looks like this. Now, if we take the derivative of this, we're going to end up with a parabola. And they want to know what is the distance between the two functions over there. So how do we calculate distance? It's top function minus bottom function. Okay, so because we're in this small interval here, we're going to have the cubic function minus the parabola. Okay, so distance equals the cubic function, that is x cubed minus x squared minus 5x minus 3, and then we're minusing off the first derivative, okay, because that's the parabola function. That's 3x squared minus 2x minus 5. Okay, so if we sort all that out, we're still left with x cubed, but then we have minus x squared minus 3, so that's minus 4x squared. Okay, let's see, minus 5 minus 2, that's minus 7x, and then minus 3 plus 5 gives you plus 2. Okay, so now we have the distance, okay, between the two. We have an expression for the distance between the two of them. Okay, now what we do is we want to find the maximum. So whenever we want to find the maximum, okay, we take the derivative equal to 0. So when we want to maximize something, so we take the derivative equal to 0. Okay, once we have the derivative equal to 0, we find all the values for the function. Okay, and then what we end up with, we check those and we see which is the highest one. Okay, so let's have a look here. The distance, well, we take the derivative of what we have there, so dx of x cubed minus 4x squared minus 7x plus 2. Okay, so that's going to equal to 3x squared minus 8x minus 7. Now we find that equal to 0. Okay, and if you check your factors, it's 7 and 1, so we just end up, oh, well, hold on, I've made a mistake here. Let's have a look here. Minus 5 plus, so this becomes not minus 7, that becomes 3, my bad. That becomes 3, which means this here becomes 3. I was going to say negative negative gives you positive. Okay, so now when we find the factors of this, it's 3x plus 1, and then over here we're going to have x minus 3 equals to 0, so we'll have x equals to, we'll have x equals to negative 1 over 3, or x equals to 3. Okay, now what we have to do is we have to substitute these two numbers back into the equation which was given. So the distance formula, yeah, got to substitute it back in and see which one gives us the highest value. Now, if you go and check, you'll actually find that this one here is going to give you the highest value. Okay, so if you check both of them by substituting them in, you're going to find that negative 3 is the one that gives you the highest value. So if you substitute that back in, so that you have negative 1 over 3 cubed minus 4 times 1 over 3 squared minus 3 times negative 1 over 3 and then plus 2, you end up with an answer of 2.52. Okay, and that's how we go about doing this question. Okay, if you guys are enjoying the content, then please leave a thumbs up on the video. It does help me out a lot. If you have any questions on the following questions, then please leave them in the comment section down below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.